All right, we are looking at 9.2 notes on graphing piecewise linear functions. So we have these inequality symbols, and I know you know this. When you see less than or greater than, it's not included. So do you include the given value? No. You would use an open circle. And if you see less than or equal to, greater than or equal to, do you include the value? Yes, so you used a closed circle. Got it? Also, same thing if you had to write something in interval notation, etc., like domain and range. If it's not included, it's parentheses. If it is included, it is brackets. Okay, so first things first, you are going to be graphing multiple things on one graph. So if you look at this, we have two separate functions. Now, if I would just cover this up, you would be graphing the line f of x, or y equals x plus 5. And you would just graph a line like you always do. Your y-intercept is at 5, your rise is up 1, over 1, and you would sketch in a line going on and on and on. But I have this little thing beside it, and it says, hey, we only want the values for this line if x is less than -2. So then I have to think a little bit differently. Instead of having this line that goes on forever, I only want the values that are less than -2. So to help my brain with this, maybe we make a table. So I'm going to pull that function y equals x plus 5, and I'm going to make a table. Now, some of you can sort of do this and you know where to start and finish. You're imagining the line and then you adjust it by its restriction. So these are called piecewise functions because you have, if you want to think about it, pieces of graphs. What is the smallest number I should put in here? Or sorry, what is the biggest number I should put in my chart? Well, I'm actually going to use -2, and here's why. I want to know exactly where it starts, and what am I going to put at -2? I'm going to put an open circle there. Because if we start at if we start at -3, I'm missing all of those numbers like -2.1, -2.001. So whatever that minimum or maximum is, in this case a maximum -2, I'm going to put in first, but I'm going to make sure I remember I need an open circle there. And then I'll just put some values in, and then I should be good to go. So it is nothing more than us taking our -2 and plugging it in. So y equals -2 plus 5, and we should get out 3. Plug in -3. Y equals -3 plus 5, and we get out 2. And 1 and 0. All right, so go ahead, let's graph that. -2, 3, we're going to put a hole. That's the starting point. And then we're going to go -3, 2, -4, 1, -5, 0. And now my line is going to keep going. I will put an arrow on it. It will go forever to the left. But this open circle is where it definitely stops. Now we have to do a second graph. So the second graph is y equals -4. And then it says the x has to be greater than or equal to -2. So I'm going to start with -2. Whatever they give me as my limit, I'm going to start with that. Would this be an open or closed circle on -2? Closed, because it's allowed to be -2. So I'm going to make a note, closed circle. Sometimes I just draw a quick closed or open circle by the point. Okay, what's my next number going to be? It says x has to be greater than -2. So what else should I put in here?
-1.
Yeah, we're going to start counting up. -1, 0, 1. No, wait a minute. My function is y equals -4. There's nowhere to put the x. No matter what you pick for x, the y value is always going to be -4. Okay, you told me close circle at -2, -4. Close circle, and then you're going to draw your points if you want to, and they're going to go this way, and you're going to have a horizontal line. Now, I want to make sure you don't get a little overzealous. This stops here at this closed circle. Okay? So, these are my two functions. I have cut everything off at -2 and above for x. And I've cut everything off that is less than -2 here. Now, do you see there's almost like an overlap there? Is this a function or is this not a function? I mean, that's sort of like my vertical line test, but this is not included and this is. So is it a function? Yes. When x is -2, I only have one y, and it is -4. All right, so this is called a piecewise function. I just wanted to show you the highlight is not part of my graph, but I just wanted to show you that idea that this is not included, but this piece is. Okay, now, what is the domain of this overall graph of both pieces? So the x value, we see it going down and to the left, and it stops here, but doesn't this include that -2? So you were right when you said -infinity to positive infinity. Now, what about the range? Okay, so this is always going to be here at 4, right? But this guy goes down, down, down forever. So you're right. The low is -infinity. And the high is not 2. The high is what you said was 3. Is that height of 3 included for the range? No, so it is a parenthesis. So you do have to slow down a little bit. Some of you can do this without making tables, but for some of us it's better because it makes our brain see. I think when I've done these on my own, I would just graph the line lightly, and then I would go back and erase anything that was less than or equal to 2 and adjust my circle. So you can do it that way as well. All right, I'm going to pull this function. The top one is y equals -2x minus 4. So I am separating my two functions. All right, I've got x and I've got y. It says x is less than or equal to 2. So I'm going to start with 2, which is going to be a closed circle. And then what am I going to do? If x is less than or equal to 2, give me my next number. 1, 0, and maybe a -1. Okay, so take it and plug it in. You know, -2 times 2 minus 4. What do I end up with? -8. All right, so plug your numbers in. Oops, I'm wrong. See if we agree. So start at 2, -8. Close circle because it's allowed to be on 2. And then go ahead and graph your line. Now, we know this is a linear function, so if we weren't getting a line, we would know something was wrong. Okay, you ready for the second one? So I'm trying to exaggerate my first point to show that that's where we're starting, and then it goes from there. So again, this is one where we cannot extend the line in both ways. It's going to be array. All right, it's saying x is greater than 2. Should I be including that 2 or not for x? Not including because it's not equal to on the second one.
Oh, the second one.
Yeah, on the second one. Okay. X is greater than 2. So what other numbers do I want to put in here? 3, 4. Okay. So if it bothers you that sometimes I'm counting up and sometimes I'm counting down, you can adjust that. I like to start with my starting number and then reread greater than and go from there. Okay, so it would be 4 times 2, which is 8 minus 9. I get -1. So go ahead and fill in some numbers. And give it a graph. We said an open circle. Are we all okay with where I'm getting these numbers from? All right, now 511 is just off the graph, but we'll be okay. All right, take a minute once you get that settled and get me that domain and range. All right, domain. My graph is, this one is going to the left, so it's pushing up, but it's pushing left for x. This one's really going pretty steep and quickly up, but it's also pushing slowly to the right. So do we agree on -infinity to positive infinity? What about the range? Okay. It doesn't go to, so the lowest point, if you think about scanning this, is -8. Why are we putting a bracket on the -8? Because it's included. And then as both graphs go, they both go to infinity, and that is your range. Okay, ready? Now we have 3, but there's a little bit more going on in here, but we can do this. All right, so first one, y equals 2x plus 4. So this is nothing new. This is very similar. I'm going to start with -3. But can I include the -3? No. So what's going to go on the -3? So do you see how I make that note to myself? I don't know if that helps your brain, but it helps mine. All right, what other numbers do I want if x is less than -3? -4, -5, maybe -6. Okay, take -3, plug it in. That's -6 plus 4, which is -2. Take -4, plug it in. So that's all we're doing. Yep. -5 should be -6, and -6 is -8. So go ahead and graph it. -3, -2 with an open circle. Don't forget that. And then remember, we're going down. Oops, daisies. -5, -6. Well, I'd screwed something up. Wait, -3, -2, -4, -4. Oh, that's why I'm off. All right, I adjusted my one point that was off, and this is going to go forever. So it is important that you do have arrows here. That does make a difference. So make sure you have arrows. What about this one? It's y equals 1. Don't skip that. Now, I could make a chart, and it goes from -3 to +4. So -3, and then, you could list all these, but we're going to be here for a little bit. 0, 1, 2, 3, 4. It doesn't matter what my x's is. What's my y always going to be? 1. Okay. Now, open or close circle. Well, we have 2. On -3, it should be closed, and on 4, it should be open. Agreed? Now, having this chart might help some of us. So if I go to -3, +1, I'm going to have a closed circle. So that's good because it doesn't interfere with that open one. And then I'm going to go over to 4, 1, open circle, and there's my horizontal line at y equals 1. But it starts and stops there. All right, then we have one more piece. Trying to find something. All right. So y equals -x plus 2. What should I start with in my xy chart? Okay. Open or close circle on the 4? Closed. Okay. And then should it be if x is greater than or equal to 4, so what should I have? 5, 6, 7. All right, so make sure you're paying attention. It's the opposite number. So -4 plus 2, which is -2. I should get -3, -4. What is it? -7 plus 2, -5. Okay, close circle at 4, -2. And then that's the start. 5, -3, 6, -4. And what am I doing? 7, -5. Okay, draw your line. Take a second, determine your domain and range. Okay, well, the domain, the graph really is going down. So it's going to keep going to the left. And even though there's a hole here, it's the -3 is included here. It doesn't include 4, but this piece includes 4. And then as it goes down, it goes forever. So even though it sort of jumps, all the x's are covered. So -infinity to +infinity. And you need to understand that's not always going to be your domain. So you want to look at it. What about the range? This one's a little bit different, so pay attention to this. How would you deal with that range? So when you look at this, the range, it just keeps on going, right? So the low is -infinity, but it does stop here. There's nothing in between. So negative 2 is the high. And even though that's not included at negative 2, this one is. So that overrides it with a bracket. Union, meaning or, and then it's just 1. That's it. Well, you actually make this bracket like that, or you could do, I would take it if you did this bracket like that. Okay. This bracket's normally showing low to high, but this is showing it's 1. That's it. You have one answer, like that roster notation. Okay, so I wanted to show you that because that one was a little bit differently. All right, now let's reverse it. I'm giving you a graph. You write me the function. Now, this one is two separate ideas. If you're having trouble seeing, this is supposed to be a closed circle, and that one is easy to see an open circle. So let's focus on this graph. I'm going to start with my function f of x. There's two graphs, and try your best to make your bracket. We need two parts to each function. What is the function and what is its limitation? Okay, so what two things do I need to write a linear equation? I need m and I need b. So on this one, the slope is what? Well, let's say we start at this point. I'm going to rise 1, 2, 3, 4, and go over 2. So it looks like I'm going up 2 and left 1. So my slope is negative 2. And what's my y-intercept on this line? Right there at negative 1. So my equation, f of x or y equals negative 2x plus 1. Now, there's more to this because my line doesn't go on forever. It gets capped off where? At what? Oh, it should be minus 1. You're right. I wrote minus 1 up there. Good catch. Okay, thank you. So yeah, that was minus 1, just like I had it. Now, the smallest x value is here at 2, right? So let's compare x and 2. I know the graph goes up, but it's going to the left or to the right? It's going to the left, so x is less than 2. Can it be equal to 2? Yes, because it's a closed circle. Okay, now we need to write our second equation. What is m and what is b? Well, m, it looks like it's going down 1 and over 1. So do we agree with negative 1? Now, I don't see the y-intercept, but couldn't I just sort of think about it? If I extended this line, what would the y-intercept be? It would be positive 4. Now, is that part of the graph? No, but that gives me that definition of my line. And so, yes. So it's y equals, and I can put in here negative 1x or negative x plus 4. And then where does the x start? At 2? And x has to be greater than because the graph is going to the right, but it cannot be equal to it. All right, now, when you first look at example 5, you might be like, oh, it's an absolute value graph. But it's not going to be done that way. It's going to be done as a piecewise one. Do you see that piece right there? That's its own line. So that's line 1. Here's line 2. And here's line 3. Okay? Now I say line. Yeah, it's segments and rays. But it's not an absolute value function. It sort of looks like that, but we have 3 pieces. So let's just number these. This is piece 1, piece 2, piece 3. Do you see what I'm trying to show you there? So here's a piece here. You have this piece right here. And then you've got the third piece. So for each of these, we need to write a function. So I'm going to write f of x, and I'm going to write a little bit bigger of a bracket. All right, what's the first one that I have in yellow? Well, the slope of that line is 0. It's a horizontal line. What's the y-intercept? What would it be if we extended it? That one in yellow right there, yeah. That would be at 2, wouldn't it? So you could write y equals 0x plus 2, but we're going to write y equals 2. That's the equation of the line. And what are the limits for x? Yeah, if it helps you guys, compare x and -4, and then you're telling me to go less than. Can it be included?
Can you have multiple conditions? Because I have multiple
Yes.
for the orange line.
Yes. Well, I'm going to write it as one condition, but you could break it up. Okay?
Oh, you do and.
Mm-hmm.
Yes.
So for this line that I have in orange, line 2, my slope is going to be negative because it's dropping. It looks like it's -1 to me. My y-intercept is at -2. We good with that? So it's going to be negative x minus 2. I got it this time. And then you actually have a starting and a stopping point. It starts at -4. That's the low. And where does it stop? At +2. Our x is in between here. So if you read it from x is going to be greater than -4, or -4 is less than x. And the x has to be bigger. X has to be less than 2 because 2 is too big. Neither of them are included because they open circles. So you could write it like that. You could also have written it something like x is less than -4 and x is greater than 2. But I think it's easier to see it this way. Okay. All right, then we have our third piece, and pull the M and the B. So I'm not trying to do this all at once. I'm focusing on each line, finding slope and y-intercept, building the equation, and then what are my limitations here? What are my constraints? So my slope is +1. What would my y-intercept be? I have -6. So y equals x minus 6. And then x has to be what? Compared to 2. And x is what compared to 2? Greater.